Okay, let me explain to you how to solve these problems related to the collision of elastic bodies for the case of direct impact. Now the question is like this. It's given that two spheres of masses m and small m, capital M and small m, impinge directly when moving in opposite direction. It's given that they are moving in opposite direction with velocity u and v respectively. If the spheres of mass small m is brought to rest by the collision, that means after impact, if the second sphere of mass m is brought to rest, then in that case we have to show that v into m small m minus em is equal to m into 1 plus e into u, where e is a coefficient of restitution. So we have to apply Newton's experimental law and the conservation of linear momentum in order to prove this result. So here what is given, let us take these two balls, two spheres of mass m, capital M and small m. And it's given that u is velocity of the first sphere of mass capital M before impact. And for the second sphere, that is of mass small m, the velocity is given to be v. So v is velocity of sphere of mass m before impact. Now let us take after impact their velocity. So I'm taking v1 to be the velocity of the first sphere, that is of mass capital M after impact, and v2 to be the velocity of the second sphere after impact. But according to the question, it's that the second sphere is brought to rest by the collision. That means v2 is equal to 0. So using this given condition, let us apply first now by Newton's experimental law. We have what is there, since they are moving in opposite direction, so the relative velocity of separation will be u1 plus, it will be u plus v in this case. So here it will become v2 minus v1 will be equal to e times of u plus v. Now, what is V2? According to the question, the second sphere is brought to rest after the collision. So that means the velocity of the second sphere after impact will be 0. So according to the question, V2 is equal to 0. It implies that minus V1 is equal to E times of U plus V. So let us name this as equation 1. And let us now apply this one by conservation of linear momentum. What is the conservation of this linear momentum? What is the linear momentum before impact? It will be capital M into u minus, since the second sphere is moving in the opposite direction, so the linear momentum or the momentum before impact will be mu minus small m into v is equal to, after impact it will be this one. It will be capital M into v1 plus m into v2. But v2 is equal to 0. It implies that mu minus small m into v is equal to mv1. So let us name this as equation 2. Now, using this equation 1 and 2, we have to prove this result here. So from equation 1 and 2, let us substitute the value of v1 from equation 1. Now from equation 1, what is the value of v1? It is e of u plus v. So minus sign is there. So it will be, you replace here v1 now by minus of e times of u plus v. So putting the value of v1 in equation 2, we have mu minus small m into v is equal to m times of v1. But what is v1? It is minus e times of u plus v. So it will be minus e times of u plus v. Simplify this one, you'll get mu minus small m into v is equal to minus meu minus mev. So transfer this one to this side, you'll get mu, then this will become plus meu. This is equal to m minus mev, and if you transfer this one small m into v to this side, then it will become plus mv, or mu here into 1 plus e is equal to in this case v is common, so it will be small m minus em. So what is the here we have to prove that v, or I can write this one, v into m minus em, that is this one, m minus em, this is equal to m into 1 plus e into u, which is the required result. So you see that by using the Newton's experimental law and the conservation of linear momentum, we are able to show this result, v into m minus em is called capital M into 1 plus e into u. Now let me come to the second problem. Two balls here impinges directly and the impact interchanges their velocities. Now prove that they are perfectly elastic. To prove that they are perfectly elastic, and we need to prove that the coefficient of restitution, or E, is equal to 1, and they are of equal masses. That means the masses also should be the same. So first of all, let us take two spheres or two balls of masses m1 and m2. So now let us take u1 to be the velocity of the first sphere before impact, and u2 to be the velocity of the second sphere before impact. And after impact, let us take the velocity of the first sphere to be v1 and that of the second sphere to be v2. Now I'm taking it in this same direction in this case. Why? Because nothing is mentioned in the question. So when it is not mentioned in the question regarding the direction of the two spheres before impact, always consider the case that they are moving in the same direction. So now here, after taking this one, so we are taking v1 to be the velocity of the first sphere after impact and v2 to be the velocity of the second sphere after impact. Now let us apply this Newton experimental law. Then in this case, what is the relative velocity of separation? It will be u1 minus u2. So it will be, and relative velocity of separation will be v2 minus v1. So by Newton's experimental law, we'll get v2 minus v1. This is equal to E times of u1 minus u2. Now, it's given that after impact, they interchanges their velocities. Now, what do you mean by this one? After impact, they interchanges their velocity. That means the velocity of the second sphere will become the velocity of the first sphere before impact, and the velocity of the first sphere after impact will be the velocity equal to the velocity of the second sphere before impact. So, according to the question, since they interchanges their velocities after collision, that means v1 will become u2 and v2 will become u1. So using this given condition in the question, so we replace this v1 by u2, or u2 minus, now v2 has, v2 has to be replaced by u1, so it will be u1 minus v1. What is v1? It is u2, so it is E times of u1 minus u2. Now see, this and this can be cancelled. It implies that E is equal to 1. That means the spheres are, the two balls are perfectly elastic. So we have proved the first part, that the spheres or the balls are perfectly elastic. Now I need to show that m1 is also equal to m2. So let us apply the conservation of linear momentum here. By conservation of linear momentum, we have, what is the momentum before impact? It will be m1 u1 plus m2 u2. So it will be m1 u1 plus m2 u2. This is equal to the total momentum after impact. After impact, the momentum is m1 v1 plus m2 v2. It is m1 v1 plus m2 v2. Or m1 u1 plus m2 u2. This is equal to what? m1. Now what is v1? Since they interchange the velocity, so again I have to use this given condition. v1 is equal to u2. So this is u2 here, plus v2 has to be replaced by u1. So it will be m2 u1. Simplify this one. Transfer this m1 u2 to this side and m2 u2 to the right hand side. Then you'll get m1 u1 plus minus m1 u2 is equal to m2 u1 minus m2 u2. So this m1 is common, so u1 minus u2. This is equal to m2 into u1 minus u2. So now you see again u1 minus u2 can be cancelled. So finally we have m1 is equal to m2. That is, these two balls have the same mass, or they have equal masses. The mass of the first sphere also will be m, and the mass of the second sphere also will is m1 here, and then the second sphere also will be m1. So we have proof now that if two balls impinge directly and the impact interchanges their velocities, then in that case the two balls will be perfectly elastic. That is, the value of E will be equal to 1 and also of equal masses, by showing that m1 is same as m2. Hope it is clear now regarding the solution of these two problems.